Hello, this is Mrs. Ward, and this is the review worksheet for section 6.1 and 6.2, Law of Sines and Law of Cosines. So the first question says, given angle A is 60 degrees, B is 79 degrees, and side A is 5.1, find the following. I want you to complete the entire triangle, sorry. If we don't draw a picture for you, draw your own picture so you can identify what sides are opposite. So here's 60 degrees for angle A. Angle B is 79 degrees, and side A is 5.1. Probably the first thing I'm going to do is go ahead and find the third angle that I'm missing. And the easiest way to do that is take the two angles that I have and subtract them from 180. So I'm going to take 180 minus 60 minus 79, and I'm going to end up with 41 degrees. So that is going to be angle C. Then one pair that I was given, the opposite pair that I have, is I was given that angle A is 60 degrees and side A is 5.1. So I'm going to start with that pair, and I'm going to say that 5.1 over the sine of 60 degrees is equal to, and let's go ahead and find B next. So I'm going to put B over the sine of 79 degrees. Now, if you're multiplying this, you're going to have 5.1 times the sine of 79 degrees, cross multiply, is equal to sine of 60 times B. So to find B, you're going to do 5.1 sine 79 degrees divided by the sine of 60. If you prefer to use end solve, which I believe most of you will, then you're just going to do end solve. And when I do that, I am going to end up being equal to 5.78. And the last proportion I'm going to have is 5.1 times the sine over the sine of 60 is equal to C over the sine of 41. So on your quiz, we're going to have to see the work. So I'm going to have to see at least these proportions and see when you solve that, that ends up being 3.86. I have to see the proportions, and then you fill in the correct blanks. The next one, angle C is 125 degrees. Side B is 4. Side C is 14. As soon as I have this opposite pair, I know that I can use the law of sines. Because of what I'm given, I have to solve for angle B first. So if I set up my proportion, I'm going to have 14 over the sine of 125 degrees is equal to 4 over the sine of B degrees. And if I'm using end solve, I'm definitely going to want to put that degree symbol in there so that it gives me my angle in degrees and not radians. When I do this, I get B, angle B to be 13.54 degrees. I do a reality check and say, does that make sense? And it does, because the largest side has to be the largest angle. So 125, 14 would be the largest side. 4 is quite a bit smaller than 14, and so 13.54 is quite a bit smaller than 125. So I have that. Now I have to find this missing angle A. So I'm going to take 180 minus 125 minus 13.54. And when I do that, I get 41.46. So that's going to be angle A. And now to find side A, I'm going to go back to 14 over the sine of 125 degrees is equal to A over the sine of 41.46 degrees, and when I do all that work, A ends up equaling 11.32. And so that triangle is now solved. Moving on to the next one, it says given the triangle and it gives me the three sides. It tells me A is 35, tells me B is 40, and tells me C is 72. When I use the law of cosines, especially since I'm probably going to switch back to the law of sines after I finish one angle, I'm always going to solve for the largest angle first. So that'll take care of that ambiguous case where I might have two answers for the law of sines. Since side C is the largest side, I'm going to solve for angle C first. So I am going, I stick to one formula. So I do 72 squared, because that's the opposite side that I want to solve for, is equal to, and it does not matter the order that I write these two in, 35 squared plus 40 squared, minus 2 times 35 times 40 times the cosine of C, and if I'm using n solve, I'm putting in C degrees. When I end up doing that, I get 147.41 degrees. So that's going to be angle C. Then to find another angle, now I'm switching to the law of sine, so I'm going to do 72 over the sine of 147.41 degrees is equal to, let's go ahead and find A next. So I'm going to do A. Oh, I did B. So B over the sine. Oh no, it's 40. What am I doing? I don't know. 40 over the sine of B. And when I do that, angle B ends up equaling 17.41 degrees. B is 17.41 degrees. And then finally, I'm going to take 180 minus 147.41 minus 17.41, and I will then answer 15.15. Then I like to check largest angle opposite largest side, smallest angle opposite smaller side. So it does check. Moving on to the next one. Given triangle A with 73 degrees. Side B is 29, side C is 27. So I still don't have this opposite pair, so I'm going to have to do the law of cosines. I'm going to have to solve for side A. So I'm going to say A squared is equal to 29 squared plus 27 squared minus 2 times 29 times 27 times the cosine of 73 degrees. And I'm going to put this in my calculator all in one shot, making sure that I put that degree symbol there, and then take the square root. And when I do that, I get A to equal 33.35. So side A is 33.35. Once I have that opposite pair, I am going to set up use a lot of sines. So I'm going to say 33.35 over the sine of 73 degrees is equal to, let's do B next. So I'll do B, and I'll do is equal to B. So 29 over the sine of B degrees. And when I do this, B ends up equaling 56.27 degrees. And then finally, I'm going to take 180 minus 73 minus 56.27. And when I do that, I get 50.73. Only this triangle is not drawn to scale at all. Just to check, the largest side, the largest angle, 73, is opposite the largest side. The smallest angle, 50, is opposite the smallest side, 27. Okay, number 5 is asking us to find the area. And to find the area, I have A is equal to 10, B is equal to 15, C is equal to 9. So the first thing I'm going to do is find my S. And so I'm going to write 15 plus 10 plus 9 and divide that by 2. And when I do that, I get 17. Then calculate the area using Heron's formula. I take 17, and then I take 17 and subtract each one of the sides. So 17 minus 15, 17 minus 10, 17 minus 9. Doing this all in my calculator in one step, and I get 43.63, and then my unit are my square units. And that's going to be my area. The next one, it says given the triangle with 55 degrees for A, B is 15, and C is 9. I'm definitely going to want to do this when I'm finding area, because if I have this side angle side, then I know I can use a lot of sines, which is a little bit easier than Heron's formula. I'm just going to take 1/2 multiply the two sides together, and then times the sine of that angle, which is 55 degrees. And when I do all that, I get an area of 55.29 square units. Much easier than going ahead and finding that side A, which some people have done. All right, a chandelier is suspended from the ceiling using two chains. One chain is 46 centimeters long and forms a 60-degree angle with the ceiling. The other chain is 64 centimeters long, and it wants to know what angle does the chain make with the ceiling. So this is the angle that I'm looking for. So right now, if I form this triangle, and if I draw it out here separate, what I have is I have 60 degrees here, 64, 46, and this is the angle that I'm looking at. I can see that I have that opposite pair, so I'm going to go ahead and use the law of sines. So I'm going to say 64 over the sine of 60 degrees is equal to, I'm going to say B over, oh no, B is 46, see, so sorry, 46 over the sine of angle B. And when I do that, I get, what do I get? I get this side here, this angle here, to be 38.50 degrees. And I guess I call that angle B, and I can call that B there. Okay, the next one. Two scuba divers are 20 meters apart. So here I have scuba diver number 1, and I have scuba diver number 2. They are 20 meters apart. They both spot a shark that is below them, so here's my shark. And the angle of depression from diver 1 to the shark, so remember angle of depression means he's looking down. The angle of depression is 47 degrees. The angle of depression from diver 2 to the shark is 40 degrees. So it wants to know how far each diver is from the shark. So I'm going to call this X, that'll be the distance diver 1 is from the shark, and we'll go ahead and call this Y, that's the distance diver 2 is. I do not have it, oh, I can form an opposite pair. I don't have an opposite pair right now, but if I find this angle here, which I can, I'm going to have that opposite pair. So the first thing I'm going to do is take 180 minus 47 minus 40, and when I do that, I get 93 degrees. So this angle down here is 93 degrees. Now I have that opposite pair, so I'm going to have 20 over the sine of 93 degrees is equal to, let's go ahead and do X over the sine of 40. And when I do that, I get 12.87 is equal to X. So this is going to be 12.87 meters, because that's meters, this has to be meters. And the next one, I'm going to do 20 over the sine of 93 degrees is equal to Y over the sine of 47 degrees. And when I do that, I get 14.41. So this is going to be 14.41 meters. So diver 1 is 12.87 meters away from the shark. Diver 2 is 14.41 meters away from the shark. Number 9, Jack and Jill both started at point A. So here's A. They start walking in a straight line at an angle of 105 degrees to each other. So Jack, let's say Jack walks this way. This can be Jack. This can be Jill. And the angle that they're forming is this 105 degrees. After 45 minutes, Jack has walked 4.5 kilometers. Jill has walked 6 kilometers. Then the question asks, at that point, how far away are they from each other? So how far away are they? Cannot do the law of sines. I do not have the opposite pair, so I have to do the law of cosines. So I'm going to say x squared is equal to 4.5 squared plus 6 squared minus 2 times 4.5 times 6 times the cosine of 105 degrees. And when I do all that and take the square root, I get 8.38 kilometers. So they are 8.38 kilometers apart from each other. Okay, there is a wire attached to the top of a 4-meter flagpole. So here's my flagpole. Here's 4 meters. And is anchored to the ground. So the wire is attached to the top, anchored to the ground. So here's my ground. Here's my wire. The wire is 4.17 meters long. What angle does the flagpole make with the wire? So it's asking what angle does the flagpole make with the wire? So this is the angle that I'm looking at. So based on this information, I'm going to make the assumption that that is a right angle. So if that is a right angle, I could do the allow signs, I guess, or because I know that this is 90 degrees, and I would have that opposite pair. Or I can just go back into SOHCAHTOA, and I'm going to choose to go back into SOHCAHTOA. I have this angle here. I have the adjacent, and I'm opposite, and I'm looking for this angle here. So the trig function that deals with adjacent and opposite is going to be cosine. So I'm going to say the cosine of x degrees is equal to the adjacent over the hypotenuse. So when I do this, I'm looking for just x, so I have to get rid of that cosine. So I'm going to do the inverse of cosine. So that will cross these two out. If I do the inverse of cosine here, I have to do the inverse cosine here. So I'm going to have x is equal to, and it'll be 16.42 degrees when I change it to degrees. All right, that's a review worksheet. I hope this helps, and I'll see you next time in class.